Hey there, my name is Researcher Roy, and I have dedicated the last 5 years of my life to researching agriculture. You see, agricultural technology has reshaped the world we live in, especially the last 200 years. It has affected how we grow our crops, how we raise our livestock, and even how we think about our food. Behind me, you see a lush green pasture, and I'm up here in North Georgia. This is actually a site that would be impossible to have seen 100 years ago. Back in the early 1900s, the Southeast was plagued by poor pastures. The native grasses could not survive being grazed upon by cattle, and the Europeans, when they brought their grasses over, they simply just died off in the summer. It couldn't withstand the heat. With no suitable grasses for the area, soil erosion was a big problem. And without pastures, owning cattle was impossible. You see, a common saying at the time was that the Southeast pastures were made of sagegrass, sawgrass, and sassafras. This all changed in the beginning of 1893 when a farmer by the name of William Suter saw a green patch of grass amongst all the brown. You see, William, he was a curious man, and he took seeds from that green grass and planted them. And then he did it again the next year, and the next year. And after many years, that grass became the primary grass on his farm, and other people began to notice. And this discovery of his would eventually transform the Southeast as he knew it. Now that grass, now known as tall fescue, covers 40 million acres of land in the southeastern United States. It has saved this area from the rampant erosion, and it even made the grass green in the winter. I researched that very same grass that William Suter discovered all those years ago. We now know that a lot of its resilience is actually caused by a fungus that lives within the grass itself. You see, the grass provides the fungus shelter, and in return, the fungus will fend off insects, nematodes, heat, drought, you name it. Scientists like me are always trying to find ways to make plants more resilient to the increasing droughts and heats of climate change. And we know for a fact that tall fescue survives better when the fungus is within it, but we don't actually understand why that is. Thus, I put the grass with the fungus and without the fungus into various climate stress situations. I then look at all these groups of grass and see how they use their genes differently. Finding these differences can help us better understand the relationship between the fungus and the grass, allowing us to truly unlock the power of the fungus and bring it to its fullest potential to make a better grass for future generations of Americans and cattle alike.